Hello friends, myself Bhau Ashok Bulakhe, Abasaheb Marathi College Rajapur District Ratnagiri. We have studied the topic carbohydrates. In this chapter, we have studied the various types of reactions and classifications of their carbohydrates. Then you know that carbohydrates produced by plants in presence of photosynthesis. In this photosynthesis, the source of energy are the diet, which is composed of the three elements, which one? Carbon, hydrogen, and oxygens. Let's now we have see the define of carbohydrates. Carbohydrates are polyhydroxyaldehyde or polyhydroxyketones, or the substances which on hydrolysis gives a polyhydroxyaldehyde or polyhydroxyketones. Now we have see the sources. Main source of carbohydrates are the plants, which is produced by photosynthesis in presence of the chlorophyll. Chlorophyll act as a catalyst. Next, classification. Carbohydrates are classified on the basis of their natures, like which are crystalline or amorphous, or the number of carbon atoms present side or ketonic group, hydrolyzable or non-hydrolyzable property, solubility of water. It is also classified into three major classes. First one, monosaccharide, oligosaccharide, polysaccharides. Only we have studied these monosaccharides. So monosaccharide are the carbohydrate that cannot be hydrolyzed to a simpler carbohydrates. Their characteristics are they are crystalline, sweet taste, soluble in water, basic unit of carbohydrates, and having the general formula CnH2nOn, where N is indicate that the number of carbon atoms. So examples of that carbohydrates like first one, monosaccharides. Monosaccharides are the glucose, fructose, ribose, etc. Then oligosaccharides are the disaccharides, glycoproteins, etc. Polysaccharides are cellulose, chitin, starch, glycogen, etc. And the glycoconjugates are the glycoproteins and proteoglycans. Monosaccharides are also classified on their number of carbon atoms. For examples, it is having a 3 carbons, name is a triose. 4 carbons, name is a tetrose. 5 carbons, name is a pentose. 6 carbons, hexose. 7 carbons having a heptose. It is also name was given like if it is a present ketonic group, name is a ketoses, for example fructose. It is a present in aldehyde group, name is a aldoses, for example glucose. Next, it is a DL notation. So DL notation which it depends on their which group and which side, which is basis on the basic structure like a glyceraldehyde. In this glyceraldehyde, the pink color OH group and which side. For example, which one right side the notation is capital D and the left side notation is a capital L. Some examples these open chain structures of the monosaccharides are theirs. So like aldopentoses having the 5 carbons. In these carbohydrates, it is a 5 carbons and 3 chiral centers. Then we can calculate the number of isomers having the formula 2 raised to n. N indicate that the number of chiral centers. In these 5 carbons aldopentoses like D-ribose, D-arabinose, D-xylose and D-lixose. It is having a 3 chirally 8 isomers are possible. Out of these 8, the 4 is a D isomer and another 4 is a L isomers at their mirror image. Similarly, we can taking the examples like aldohexose, it having the 6 carbons and the 4 chiral centers. Therefore, you can calculate this isomer, it produces the 16 isomers. Out of these 16 isomers, the 8 is D isomers and 8 is L isomers. So these 8 isomers like D-allose, D-ultrose, D-glucose, D-mannose, D-glucose, D-iodose, D-galactose and D-talose. Now we can see we can draw the Haworth formula of the carbohydrates. Firstly, one thing are important to know that the we can draw the Fisher formula. In the Fisher formula, the two groups are there like which on which side means right hand side and left hand side. Right hand side the group we can draw below the plane of ring and left hand side we can draw the above the plane of the ring. This after drawing this group we can rotate the C5 carbons. It shows that the OH group is near to carbonyl carbon. Lone pair of this carbonyl carbon is attack on carbon get the new chiral center and produce two anomers. One of the anomers having the OH is below the plane and another OH is above the plane. The OH is below the plane, the name is alpha D glucopyranose, and OH is above the plane, the name is beta D glucopyranose. Similarly, this anomer we can draw in the chair form, like which is axial group and which is a equatorial group. Also, we can draw the Haworth formula of D-glucose in the form of glucofuranose. We can see that in pyranose ring it having a 6-membered ring and furanose ring are the 5-membered ring. So firstly we can write the Fisher formula, and in this Fisher formula we can draw the Haworth formula of D-glucofuranose. In the hexagon ring we can draw, and in this hexagon ring the right hand side group we can draw below the plane and left hand side group it is above the plane. Then we can rotate the C4 carbons anti-clockwise direction. After rotation, the OH group is near to carbonyl carbon and which is attack on this carbon to get the new chiral center having the 5-membered ring. So name is a furanose. So one of these OH is below the plane, name is a alpha D glucofuranose, and another anomer like OH is above the plane, name is a beta D gluco. Similarly, we can draw the Haworth formula of another carbohydrate having the 6-membered ring or the 5-membered ring like the D-ribose, D-galactose. We can draw the furanose as well as pyranose ring. Now we have seen that existence of carbohydrate in the ring structures. Some evidences are there to give the which types of carbohydrates like a chain structure, open chain or cyclic structures. The firstly which has studied the polyhydroxyaldehyde. You know that glucose does not form bisulfite compounds. Another, it does not give color of chips reagent. Glucose shown mutarotation means it shows that it is exist in two isomeric form. But you know that normal aldehyde reacts with 2 moles of methanol and 2 form dimethyl acetals. But glucose does not react, and it react with only glycosides, and two glycosides does not shown with the open chain structure. Glycosides and pentaacetal as well as pentamethyl do not show carbonyl property of meta rotations. Now we have studied the polyhydroxy ketones. Polyhydroxy ketones like a fructose, it is also does not form the bisulfite compound. It shows mutarotation and to form two isomeric structures, does not form the open chain structure. Monomethyl glycosides and fructose does not exist, and the phenomena name is a mutarotation. But you know that normally ketone react with 2 moles of methanol to give ketone. But fructose does not react with 2 moles, it reacts only 1 mole. And it hence it cannot explain the open chain structures of the carbohydrates. Also, we have studied the formation of cyclic structures of carbohydrates. The aldehyde and ketones react with hydroxyl group of alcohol and to form hemiacetal or hemiketals. It is a tetrahedral nature of carbon atom, the open chain structure bent in C shape, and hence the monosaccharide, the aldehyde and keto group is close to gamma or delta hydroxyl group, and therefore they react intramolecularly and to form the oxide ring, like 5-membered oxide ring name is glucofuranose, and 6-membered oxide ring is pyranose. Then features of oxide ring. The first one, in case of aldohexose, the aldehyde group is a C1 carbon which is react with C4 or C5 to form the 5-membered or the 6-membered cyclic hemiacetals. In case of ketohexose, the keto group like C2 react with C5 or C6 to form the 5 or 6-membered cyclic hemiacetals. 5-membered oxide ring is called as a furanose from furan ring, and 6-membered ring is called as a pyranose, which is based on the heterocyclic ring of oxygen called pyran. The formation of oxide ring, the new asymmetric carbon atom is created at the and called as an anomeric carbon atom. The two different configurations are possible. Which one? If OH group on the right side is called as alpha anomer, and the anomeric group on the left side called as a beta anomer. The alpha anomer is obtained by crystallization the sugar in water below 50 degrees centigrade, and beta anomer which is obtained in hot water or the pyridine at 100 degrees centigrade. Next, the some terms we have studied. The first term is a enantiomers. You know that enantiomers, the isomers which are non-superimposable mirror image of each other is called as a enantiomers. For examples, these examples are shown here. The pink color of this group are superimposable, non-superimposable mirror image. Then next term, diastereomers. The isomer which are not mirror image of each other, or they differ or specific rotation or the direction of both. This is called as a diastereomers. For examples of these carbohydrates are shown that all these groups are don't match with each other, therefore it is diastereomers. Epimer, what isomers in which differ in configuration only at the asymmetric carbon which is at the alpha position to the carbonyl group is named the epimer.